7.3, we're getting into multiplying polynomials. So our learning goal, I will multiply binomials by using the distributive property the FOIL method, or using a table. And I will multiply binomials and trinomials. So this gets into some really fun stuff. If you've ever heard of foiling before, that's what we're going to be doing. To start off with, let's just do a really quick refresher. 5 times x plus 2. We need to use the distributive property here. And the distributive property says if you have something on the outside of parentheses, everything in those parentheses needs to be multiplied by what's on the outside. So this would be 5 times x plus 5 times 2, or 5x plus 10. Today we're going to do the distributive property, but instead of having a monomial times a binomial, we're going to have a binomial times a binomial. So the first way we can do this is by using the distributive property. Let's change you to red. So what I'm going to do here is by just using the horizontal method distributive property. Everything in these parentheses has to be multiplied by everything in these parentheses. So I need to do x times x, so the x from the first one times the x in the second one, and then I need to do x times 2. So x times x, x times 2. And then I need to do the same thing here, where I need to do 5 times x. Oops, that x is supposed to be blue. That's what I get for trying to do fancy colors. And 5 times 2. So this x was multiplied by the x and the 2, and this 5 was multiplied by the x and the 2. So everybody got paired up with everybody else. This is just using the distributive property. You're probably never, ever going to do it this way. We wrote all those out. X squared plus 7x plus 10. This is kind of a messy way to do it. Instead, what you're going to do is you're going to do either using a table or, like I said, by using the FOIL method. What I would do is I would probably FOIL it. So what that means is FOIL stands for first, outside, inside, last. And really foiling is using the distributive property. It's just a neater way, or it's like a method to make sure that you're covering all of your bases. So if I had this x plus 5 times x plus 2 again, first, what that means is multiply the first terms by each other, the first in each set of parentheses. So that's x times x. O stands for outside, so you multiply the outside numbers by each other. So 2 times x. Next is inside, which is 5 times x. And then last is 5 times 2, which is 10. So we have x squared plus 2x plus 5x plus 10. And you're looking at that and you're saying, Mrs. Bergman, that's identical to what you did up here. And it is, but with this one, I thought of this method. I did the first, the outside, the inside terms, and the last terms. With this one, it's just like, oh, make sure everything gets multiplied by everything else. This is just a method for keeping everything straight. So I get x squared plus 7x plus 10. So if you just remember FOIL, first, outside, inside, last, you will never go wrong with multiplying 2 binomials by each other. Another option is by using a table. And the table can be kind of nice because it gives us a good visual representation. So if I wanted to multiply 3x plus 1 times x minus 4, what I would do is I'd set up a table like this. 3x plus 1 and x, and that's going to be a negative 4. That's adding a negative 4. And what I'm going to do is I'm going to multiply these out. 3x times x is 3x squared. 1 times x is x. 3x times negative 4 is negative 12x. And negative 4 times 1 is negative 4. So this is just another way of making sure that everything in these parentheses got multiplied by everything in these parentheses. And then I'd add them together. 3x squared plus x plus negative 12x minus 4, or 3x squared, it's going to be plus a negative 11x, or just subtracting 11x, minus 4. And again, you would have gotten that exact same answer if you had FOILed. First would be 3x times x. Outside would be 3x, and that's a negative 4, right? Adding a negative 4. So negative 12x. Inside would be 1 times x, which is x. And last would be 1 times negative 4. Combining this would be 3x squared minus 11x minus 4. We get the same thing. These are just two different ways to think about it. I'm going to say that the table method, maybe for two binomials, isn't necessarily super helpful if you're okay with the foiling, but this table method is going to be more useful when we're doing something like multiplying a trinomial times a binomial, or two trinomials. It can help keep everything organized just a little bit better. So our big thing here is making sure that we're careful with negatives. So let's do some more. I'm going to do more using FOIL. If I had x minus 3 times, how about x plus 9? If I wanted to use the FOIL method, first is x times x. That's x squared. Outside is x and a positive 9, which is 9x. Inside, I'm subtracting a 3 and multiplying that by x, so that's a negative 3x, or subtracting 3x. And then I have this negative 3 and a positive 9, makes negative 27. From here, I want to combine my like terms, so this will be x squared. A positive 9x taking away 3x is 6x, minus 27, and I'm done. So first, outside, inside, last. That tends to work pretty well for FOIL. We can do a slightly trickier problem the same way. If I had 4n minus 1 times 2n plus 5. First is 4n times 2n. Outside is 4n times 5. Inside is negative 1 times 2n. Last is negative 1 times 5, so I'm really thinking of that as adding a negative 1 there. 4n times 2n, 8n squared. 4n times 5 is 20n. Negative 1 times 2n is a negative 2n, and I'm taking away 5. Combine my like terms. 20 take away 2 is a positive 18n minus 5, and I'm done. So you just want to keep practicing these, doing them over and over, and hopefully you'll be all set. Now, if I wanted to multiply a binomial by a trinomial, though, that's where it gets a little more complicated. So here I have a binomial. I have 2 terms, and a trinomial. There are 3 terms, and I want to multiply these by each other. Again, I could do this using the distributive property, where I would do b times b squared plus b times 2b plus, or actually minus, b times 7, and then negative 3 times b squared, and negative 3 times 2b, and negative 3 times negative 7. But it can be really easy to skip terms. So instead, I'm going to do this one as a table, where I have b, and think about that as adding a negative 3. And then going down the other side, I have b squared, a 2b, and a negative 7. And I'm going to multiply these out. b times b squared is b cubed. Negative 3 times b squared is negative 3b squared. b times 2b is 2b squared. Negative 3 times 2b is negative 6b. b times negative 7 is negative 7b. And negative 7 times negative 3 is a positive 21. So you can see I have a bunch of terms here that I then want to write out. I'm going to go from highest degree to lowest. So I have a b cubed. I'm taking away 3b squared. That's a positive 2b squared. I'm taking away 6b, taking away 7b, and I'm adding 21. I have 6 terms here. I have 1, 2, 3, 4, 5, 6 terms here. So now I just want to combine them. There's only one b cubed term. Then I have negative 3b squared plus 2b squared. Leaves me with a negative 1b squared, or subtracting b squared. Negative 6 and negative 7 make negative 13b. And then I add 21. My exponents go 3, 2, 1. So I don't have any more like terms to combine. And that is my final answer. So hopefully you can see how a table was really helpful there. I don't have something like FOIL for a binomial times a trinomial. So the table, I think, can be a really useful way of doing it because it keeps everything organized for you. So that is basically the whole lesson on multiplying polynomials. So again, this is something you're just going to want to practice a lot. There are a lot of practice problems in the book that you can do. Of course, you're going to be assigned some, but you can always do a couple more just to get more practice, because the more you do, the better you're going to get at it. So go for it.